Good morning, class. So this stage we are busy with page 157. You had homework on exercise 6, I think it was, no? You had to do the even numbers. Yeah, the even numbers. Any issues there? On to exercise 6, the even numbers. Sorry? So numbers 1 to 14. Let's start there. So it's 2 to 14. Just hang on. This is exercise 6 on page. Which page is this on? 155. Exercise 6, page 155. So 2 is fine. No? 4, 6. 8 is fine. 10? 10, okay. So they want to know the derivative with respect to x. So what I'm going to do is I'm going to change that to exponential form first. So that will be x 5 over 3 over x minus x 1 over 2 over x. You don't have to write it like that. So I'll just do it so that it can be easier to simplify. Again, I can't apply the derivative as it stands there. So 5 over 3 minus 1 is x, 2/3 minus a half minus 1 is negative half. Okay? You all agree with that? Can I apply my derivative now? Since it's in the form of ax to the exponent n, so yes, I drop this. So it will be 2 over 3x minus 1 is going to give you negative a third. Negative half times negative 1 is positive half, x to the minus 3 over 2. But the question says you must leave your answer in positive exponents, not so. So that's simply going to be 2 over 3 x to the half to the third plus 1 over 2 x to the 3 over 2. You don't have to go further than that, but it could also be written as 2 over 3 the cube root of x plus 1 over 2x and the square root of x. Okay. Because 3 over 2 can be written as 1.5. So that x to the 1 times x to the half. Remember that's x 1.5 now. No? Could be broken up into that. Remember when you multiply and base the same, you add the exponents. So that's going to be x to the 1 root x. That's how I get that. 2x root x. Okay. But as I said, it's not required. It's just another extra step there. There's some textbooks writes it in radical form as well. Okay. Number 12, any issues there? No. Number 14? Yes? Some serious? Okay. So we got y is equal to 2/3, x to the exponent 2 over 3 minus x to the half. I can apply my derivative, so dy over dx. So 2/3 times 1 is 2 over 3 x. You subtract 1 from that, I get negative a third. Minus a half times 1 is negative a half x. Minus 1 from that is going to give you the minus 1. Which now can be written as 2 over 3 x to the third, because I want to write with positive exponents, minus 1 over 2x to the half. Again, you don't have to write it in the radical form. So it's 2 over 3 the cube root of x minus 1 over 2 square root of x. Okay? Then you have to do these even numbers here. Any issues with number 16? Yes? So ds over dt, the derivative of s with respect to t. So s is going to, if I cube that out, I get 1 t cubed. Nope, I don't want to make a mistake. This is t minus 3 anyway, that's going to be t minus 3 times t minus 3 squared. Not so. So t minus 3 squared is going to give you t squared minus 6t plus 9. So you multiply this out, I get t cubed minus 6t squared minus 3t squared is negative 9t squared. 3 t times 9 is 9t minus plus 18t is 27t minus 27. And this is all over t to the third. Okay, you all okay with that? Now we put each one of its own, so it's s. So it's going to be t cubed over t to the third. It's going to be t 8 over 3. Let's check if that's correct. Right, minus 9t. 2 minus a third is going to be 6 is 5 over 3 plus 27t. 1 minus a third is 2/3 minus 27 over t to the third is going to be 27t to the minus a third. You all agree with that? Now it's in the form of a x to the exponent n. Can you see that? It's now in that form. So now we can apply the derivative. So ds over dt is going to be 8 over 3 times 1 is 8 over 3t minus 1 is going to give you 5 over 3. Negative 9 times 5 over 3 is negative 3t minus 1. You're going to get 2 over 3. Plus 27 times 2/3 it's 9, it's 18t minus 1 is negative a third. Plus 27 times 1 over 3, or negative 27 times negative 1 over 3 is going to be 9t minus 1 from that, and again negative 4 over 3. Again, we're going to write this with positive exponents. Is 8 over 3t to the 5 over 3 minus 3t 2 over 3. Yes? Sorry? 15. Okay? So 9 times 5 over 3. So it's 3 is 15. You're absolutely correct. So that's 15 here. No? Thank you. Sorry about that. See, holidays is bad for us. I'm joking. My mistake. 9 over t 4 over 3. Again, you don't have to write it in a radical form, but again, it could be written in radical form. So it's 8 over 3. There's one whole t, so it's t root. There's a cube root of t squared minus 15, the cube root of t squared minus 18 over the cube root of t plus 9 over is 1 full t root the cube root of t. Okay. Guys, got what you need? Any problems with 18th? Yes? Don't forget to ask that guy why he doesn't write an equal sign in. You're going on Saturday. No, don't forget. So it's going to be d of x. So again, change everything to radical to exponential form. So it's x5 over 2 minus 3x squared plus 2x to the half, each one of its own. It's going to give you x to the third. You don't have to write each one of its own. If you can do it in your head, it's fine. Okay. So I'm still simplifying. So that's going to give us x What is 5 over 2 minus a third? So put in the calculator. 5 over 2 minus a third gives you 13 over 6. Okay, minus 3x2 minus a third is 5 over 3 plus x, 2x, sorry. Yes? Absolutely. Why only ask now? I almost done this one. But you're right. How did I get it? There must be a 2 there, not so? So it's x3 over 2, x3 over 2, x3 over 2. So let's go again. So it's 5 over 2 minus 3 over 2 gives you 1. Yes. Minus 3x, 2 minus is going to be half, plus 2x, negative 1. Is that correct? Right. Can I apply a derivative as I stand here? Yes, I drop the d. So it's going to give you 1 minus 3 over 2x minus 1 will give minus half. 2 times negative 1 is negative 2 x to the negative 2. Because of the negative exponent here, you go down. So it will be 1 minus 3 over 2x to the half minus 2 over x squared. Again, you don't have to write it in radical form. So it's 1 minus 3 over 2, the square root of x minus 2 over x squared. Let's go. Any problems number 20? No? Number 22? Sorry? Yes. So what we need to do first is to multiply the story out. Okay? Did you do that? So it's d over dx. Multiply it out, I get 8x cubed plus, that's going to give us 12x. No? 12x squared minus 12x squared. So that cancels, no? Then, but this will result in the difference of cubes. Can you see that? So that's going to give you negative 27. That's what you're supposed to have ended off with when you multiply it up. It's different. Okay, so what was your sum for number 22? This is, hang on, so this would be 24x squared, and that falls away, no? Derivative of a constant. What was your sum?
I got
d over dx, yes? Yeah?
and it was 2x minus 34x squared.
Minus 34x squared.
Yeah. Plus 6x plus 9. And it
And that's it?
yeah.
So then if you apply a derivative, you're going to get 12 minus 68x. Huh? What is this? Is it 2 then? Okay? Plus 6. And then this is like terms, so it's going to give you 8 minus 68x. Is that what you got? Yeah. It will only be minus 1. It will actually never be minus 1 when you apply a derivative at this point. So that is some other ball game that you're talking about. goes into lin and those things, the natural log, which you guys won't be doing now. 24?
Yes, sir.
So f of x is going to be 2x3 over 2. Again, I'm not applying the derivative to part of the sum. I apply the derivative one time. So that will be 2x to the exponent 3 over 2 minus 5x to the half. Bring that x to the half up, becomes plus 2x to the minus half. Now I can apply my derivative. So f prime x equals 3x to the half minus 5 times half. 5 over 2x minus 1 is minus half. 2 times negative half is negative 1x minus 3 over 2. Okay? Positive exponent, so it's 3x to the half minus 5 over 2x to the half minus 1 over x to the 3 over 2. Again, you don't have to write this in radical form, but this would, f prime x could also be written as 3 root x minus 5 over 2 root x minus, there's 1 whole x there, so it's x root x. Okay. Number 26. Number 28. Alright, so that brings us now to important rules. We did the examples out of this. We spoke about all the examples. You had to do exercise 7 on page. Exercise 7, page 156. Sorry? 157. Okay. Alright, any problems with number 1? 1.2. It says show that, okay, so it's a left and right hand side story, not so. However, I need to know what f of x and g of x is. Okay, put this at the bottom. Take this out. Okay. So, on the left hand side of the equal sign, we have d of x, the derivative with respect to x of f of x. What is f of x? 3x squared minus 3 times the derivative with respect of x of g of x, which is 2x cubed plus 2x squared. Not so? So apply the derivative, we now get 6x times, the derivative here would give you 6x squared plus 4x. Get rid of the brackets, it's going to give you 36x cubed plus 24x squared. So that's the left hand side. The right hand side says you got the derivative with respect to x of f of x times g of x. So f of x is 3x squared minus 3. G of x is going to be 2x cubed plus 2x squared. So before I can apply my derivative, I must multiply the story out, which now gives me 6x5 plus 6x4 minus 6x cubed minus 6x squared. So if I apply my derivative, this mustn't be here, no? Apply the derivative, it's going to give you 30x4 plus 24x cubed minus 18x squared minus 12x, which is of course not equal to the left hand side. You see, because this is the left hand side. So is the answer the same? No. So it's not equal. Any other problems with number 1? Number 2? 2.3.3. No, this is 2.1 first. Any issues here? 2.1? No? 2.2? 2.3.3, right. Sure, you too fast. It's fine. 2.3.3. Okay, so the question was the derivative, you must show that's equal. So the derivative with respect to x. What is f of x? This is the left hand side, no? What is f of x? So f of x is x squared minus 4x. That it? Right. So if I multiply the story out, I'm going to get the derivative with respect to x of kx squared minus 4kx. Okay? If I apply my derivative, so it's going to be 2 times 1k is going to be 2k, minus 1 is x, minus 4k. That's all. We're looking at the right hand side. So that is k and the derivative with respect to x. Okay, so here you're going to apply a derivative first. So x squared minus 4x, which is going to be k into derivative of x squared is 2x, derivative of negative 4x negative 4. You multiply the k in, which is going to give you 2kx minus 4k. What do you notice? They're the same, which is equal to the left hand side. Okay? What's the next problem? Fine. Okay? Two point 3.5. Again, left and right hand side story. So the left hand side equals the derivative of x, of f of x. What is f of x equal to? X squared minus 4x. 2x minus 8. So according to this here, I must simplify it inside the bracket first. The derivative with respect to x, I don't think this is equal. So this is going to go into the quotient rule. Okay, but okay, let's see. So that's going to give us x into x minus 4 over 2 into x minus 4. That cancels. Leaves you with the derivative with respect to x of x over 2. Now that's the same as saying the derivative of x, which is half. There mustn't be an equal sign. This is half x, no? Apply my derivative, I get half. If I look at the right hand side, so here they want to know the derivative with respect to x of f of x, which is x squared minus 4x. And that's over the derivative with respect to x of g of x, which was 2x minus 8. That's all. So if I apply my derivative here, so that's going to give me 2x minus 4 over the derivative in your denominator is 2. Each one of its own. It's going to give you x minus 2, which is not equal to the left hand side. Not so. So they made a mistake here. They put the not equal sign. So this is going to go into quotient rule. And that is not the case. Okay. It's a quotient rule, the division rule of differentiation. So they made a mistake there, but it's fine. We make more mistakes than them, no? Not so? Are we right? Am I saying the right thing? I will say yes for your part. Okay. So you guys don't speak to me. People, any problems with number 3? You only do 1 and 2. Boring. Would you like to do number 3 and 4? For people who's silent, that's was approval. No? You guys know that rule already. No? You are quiet, it means to say yes. Yeah? If somebody asks you something and you don't want to say yes or no, it's considered as a yes. Yeah? Don't you guys know that? What do you guys do now? No? Discuss those things. Discuss that, discuss taxes, discuss how to buy a house. Start discussing those things. No? Yeah, okay. So you're going to do 3 and 4. Oh my word. So, okay, homework 3 and 4. Right. And you guys had a test. Did I give you this test back? Or was this a test that I just gave you because we didn't have time? Okay. Can we answer it quickly? Or you guys don't want to answer this? Have you answered it in your books? Oh my God. Okay, so silence means yes, no? Right, so we're looking at class test 4 term 2. Oh, you guys are supposed to have written a test today.
No.
Right, but okay, it's fine. You'll write on Monday, okay?
Yes, sir.
Right. Determine the equation of f to the negative 1 in the form of. So what do we do for the inverse function? We interchange x and y. So x is equal to 1 over 3 y squared. Divided by a third both sides. So 3x is equal to y squared. Introduce square root. Must not forget plus minus. So it's plus minus the root of 3x. That's your inverse. It's actually not supposed to be that. It's supposed to have been y is equal to. Why? Because the f denotes it is a function like this. Okay. So that's that. Let's look at number 1.2. On the same set of axes, sketch both graphs, clearly indicating the intercept of the axis as well as another point. Right. So what do we have here? What's the equation of the first line? The first of the graph itself of f of x. 1 over 3 x squared. So it gives you a third, 0 and a third. Not so? So you got 1 and minus 1. That's 1. So it's 1 and a third. Minus 1 and a third. It's going to go through the origin. So that is your f graph. So what do we do for the inverse function? We interchange x and y. Third, 0 and a third. So if x is a third, y is 1. And if x is a third, y is minus 1. We're going through 0 and 0. Okay? And that is your inverse. Alright? And that is always reflected in the line. Y is equal to x. 4 marks people for something. Okay. Next question. If the domain of f were x is an element of 0 to infinity, that means to say that they're considering this part of the graph only. And you see 0 to infinity. Would the inverse be a function? So if it was that part of the graph only, which means to say that is the part that would be drawn only. Not so. And if you reflect that in the line y is equal to x, you must interchange x and y. 0 and 0 remains 0 and 0. 1 and 3 becomes a third and, 1 and a third becomes a third and 1. So is this inverse here a function? Yes. Why? Passes the vertical line test. Not so. Let's look at the next question. Number 2. Determine if g of x is equal to 3x minus 6 over x, determine g of 3a. So if I see x, I put a 3a. So it's going to be 3 into 3a minus 6 over 3a. That's going to give you 9a. Not so. 3 has a common factor. I'm left with 3a minus 2 over 3a. That cancels, leaves you with 3a minus 2 over a. Okay. Very simple. The next one. You are given that f of x equals 2x to the power 4 minus x cubed minus 11x squared plus kx plus 12. Find the value of k if the remainder is 60 when it's divided by x minus. So what do we do with that? See that equal to 0. So x equal to 3. So I now work f of 3. F of 3 gives a remainder of 60. You would have said the factor in the remainder would have been 0. Okay, so that gives us 2 times 3 to the 4 minus 3 cubed minus 11 times 3 squared plus k times 3 plus 12 equals 60. So that is simply 2 times 3 to the exponent 4. Oops. Minus 3 cubed minus 11 times 3 squared plus 12 gives us 48. So 3k is equal to 60 minus 48, which is 12. Okay, so k has to be 4. Alright? Nice reminder theorem questions. And then the last one here. Solve for a and b if x minus 1 and x plus 1 are factors. People, factors mean to say must be equal to 0. Not so. So we substitute x is equal to 1, then you get a times 1 cubed plus b times 1 squared plus 5 times 1 minus 5 equal to 0. We keep a as the subject of the formula, so minus b, that cancels. Not so. So a is minus b, that's 1. When you do the other substitution now, see that equal to 0, so x is equal to minus 1. When you substitute x is equal to negative 1, you're going to get a times negative 1 cubed plus b times negative. Wherever I see a x, I put a negative 1. Since it's a factor, I set it equal to 0. So negative a, there must be a square there, plus b, and that cancels again, equals 0. This is equation 2. So if I substitute equation 1 into equation 2, you will get therefore minus b plus b is equal to 0. So there's going to be 2b is equal to 0, so b is 0. Substitute that back, a is going to be minus 0, which is 0. So a is 0 and b is 0. Is that correct? Huh? Did anybody try this out? You can't apply the rule on you people because you guys are quiet for yes and no answers. Alright. Did we conclude the chapter on polynomials? Have we completed the chapter on polynomials? Okay, I would say yes. Okay, so delete that. Delete that. Alright, so at this point, okay, so now we're looking at finding the equation of a tangent to a function. This was exercise what? This was exercise 7 on page 157. Hello? Yes, I am. I am? Yeah. Yeah. Yeah, that's correct. Yeah. Diane. What's the surname? No, I'm Muhammad.
Good morning, may I have your attention please? Chloe Euster Palmer, if you can come to the office for a collection. Chloe Euster Palmer, to the office for a collection. I have a small green bag in lost property, a black beanie, and 2 pairs of glasses. Then the grade 12s are selling eats from the kitchen. They're selling the hot dog combo for 25 Rand, the single hot dog for 15 Rand, and the cool drink for 10 Rand. Please support the grade 12 tuck shop, running from the kitchen in the reception area.
Okay. Finding the equation of tangent. People, we have done this already, not so? Okay. So what I want you guys to do is read through the example on page 158. I was going to do it with you, but as you can see, time ran out. We have done this already. We have worked out tangents to graphs, not so? Right. So for homework, I would like you guys to do exercise 8. Answer what you can. Whatever you can't answer, I will answer on Monday, inshallah. Okay. People, enjoy the rest of your day and your weekend. Good morning, class.